Hi, in this video we'll see how to create a new project in Cyber Workbench and do high level synthesis and analyze the resource utilization. So first let us create a new project. Before that we'll create a workspace for the project. So workspace name will be AV8 because the project you're doing is running average of 8 numbers. We'll name it as AV8. And the project name is also AV8. Okay. The project is now created. Now let us set the project options. So the clock frequency should be 50 megahertz. So it should be 2000 here, and it's FPGA, and the family name is Cyclone 5. Speed grade is -6, and device name is 5CEMA5. 5CSEMA5, sorry. And the package name is FC31. Okay. Logic synthesis tool is Quartus 2. And now let us apply, and we are done. Okay. Now let us import the source file. Now we want to analyze the source file for any errors. Okay. For now we are not having any errors in the source file. So the file is generated, which means there are no errors in the source file. Now let us set the synthesis options. So it is in automatic scheduling, and I think rest all others are done. Okay. Now we will generate the constraint file, which will have the resources that is to be used. So we'll go to generate constraint, FCLB and FCNT, and we'll change this. The maximum functional units to 10, and click generate. So if you see here, our constraint file should be generated. Let's check this constraint file. The constraint file is generated. The element is 4 8-bit adders and 3 12-bit adders. Then now let us generate the RTL for this synthesis. Generate RTL. Okay, now we have the QOR report. Let's have a look at the QOR report. So the module name is average of 8 AV8, and let's look at the resource utilization. Okay, the total LUTs used is 69, the number of registers used is 64, and the clock period is 20 nanoseconds, which means 50 megahertz, and the critical path delay is 2.054 nanoseconds. So 1 by this will give us the maximum frequency with which the circuit can operate. Now let us also look at the data path. If you go here, it should be. So this is the data path of our circuit, you can see the adders. This is an 8-bit adder, and this is another 8-bit adder, and this is a 12-bit adder. So we are having four 8-bit adders in the SCNT file. So let us check. Oh, we are having, this is an 8-bit. So we are having four 8-bit adders and three 12-bit adders, and we can also look at the signal table. So this is the signal table. Now we'll look at the generated RTL code, and sorry. So this is the generated RTL code from the C code which we provided. Okay, thank you.